Okay, IPv4, Internet Protocol, version 4. It is the fourth version of the Internet Protocol, but it's the first version that really mattered. And so let's talk about what it is and specifically what its addresses look like, because its addresses make the whole internet work. So in this video, we're going to talk about what the format of an IPv4 address is and what the subnet mask is and what the subnet mask does. How does it work? So the format of an IPv4 address, it's 32 bits. That's it. It's 32 ones and zeros. And typically, those 32 ones and zeros are represented in a very specific way, and that is in a dotted decimal format. That's 4 bytes separated by dots, and each of those, each number is representative of a single byte, or 8 bits. And that's really it. This is the format you're going to see almost every time. It's not the only format out there. There's lots of different ways to format an IP address. For example, you could see hexadecimal. This is very uncommon. But it's the same thing because it's the same thing. It's just a different way to represent the ones and zeros that make up the 32 bits of an IPv4 address. So it's good to know that it's possible, and you could see it like that, and especially if you're looking, say, in Wireshark at the ones and zeros, the hexadecimal bits and bytes that are making up an IP address, you will see those hexadecimal numbers. So it's good to know that they're there. You might also occasionally, but only very occasionally, see it represented as binary. All ones and zeros. And this is 4 different ways, or 3 different ways, to represent the same number. So it's ones and zeros. Again, I mean, that's all it is. And I can say it a bunch of different ways, and I can show it a bunch of different ways, but it's ones and zeros here, ones and zeros here, ones and zeros here, in each case representing the same numbers. So a subnet mask is what tells your computer, or what tells the network interface, where the network address ends and the host address begins. We'll talk more about that. But the subnet mask is also 32 bits long, and it's also ones and zeros. The difference is that where the IP address could have, just a second, could have ones and zeros all mixed in together. The subnet mask, ones and zeros, it's all ones, and then it's all zeros. And every time you see a subnet mask, that's what it looks like. It's all ones and then all zeros after that. And again, it could be represented in dotted decimal. It could be represented in hexadecimal. It could be represented in binary. But in either case, all ones, then all zeros, making up the subnet mask. And that's the rule. And like I said, the subnet mask tells you where the network address part of the IP address ends and where the host ID part of the IP address begins. So let's take a look here. On the top, we've got our IP address, and it's all ones and zeros, because remember, that's what it is. On the bottom, we've got our subnet mask, and it's all ones and zeros, because that's what it is. And where the subnet mask makes that jump from ones to zeros, because that's what it is. Remember, all ones, then all zeros. Where the subnet mask makes that jump is where the network ID ends, and where the host ID of the host on the network begins. And everything before that is part of the network address. Everything after that is just a host ID. And again, it's all 32 bits. So we've got network ID up till that last dot, or up to the first 24 bits in the 32-bit IP address. And that's what it is. So the network ID would be 207.173.75.0. Don't worry about the numbers exactly, specifically. Just know that that's where what the subnet mask does and how it split things up. We will get very heavily into how to do the math to figure this stuff out later on. So again, the subnet mask rules, quick refresher, all ones followed by all zeros every time. And where the ones end and the zeros begin is that network address boundary, or where the network address is. So here are some examples of subnet masks that work. This one is a good subnet mask. It's all ones followed by all zeros, so it works. This one, I snuck a zero in way over there. I can't even point this far. My hand, see if right about where my hand is. You can't even see it, but it's there. over there you see the 0, that makes that an invalid subnet mask. You will never see a number that's not all ones followed by all zeros in a subnet mask. So 128 is 1, 0, 0, 0, 0, 0, 0, 0, 0. I think that's 7 zeros. So that makes it a valid number to see in a subnet mask. 129 is not. So again, you'll get lots of practice with this, just starting to introduce the topic. So numbers that you will see in subnet masks and numbers that you should start to get familiar with, because you're going to see them over and over again, are the binary numbers that are either all zeros or all ones followed by all zeros. So in a byte, you will see zeros, all zeros is 0. 1 followed by 7 zeros is 128. 1, 1 followed by 6 zeros is 192. So you'll see 192, 128, 224, 240, 248, 252, 254, and 255, representing that full spectrum. Those are the only valid numbers you can see in a subnet mask, and obviously those are only valid for the last non-zero number in a subnet mask, because everything before that's all ones, so you will see some 255s on one end, some zeros on the other end, and one of these numbers in the middle, representing where that split happens between the network address and the host ID. So you also see the subnet mask represented in a different way, represented in what is called the CIDR slash notation. We can just call it slash notation for short. CIDR stands for classless interdomain routing, which is a long thing that has another context that we'll talk about in a different video when we talk about different ranges of IP addresses. But for now, just know that slash 24 represents 24 ones in the subnet mask, which is 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 24 of those up until there, and then the remainder up to 32, so 8 zeros. So in that case, 24 slash 24 is 255.255.255.0, because that's 24 for 3 bytes of ones followed by 1 byte of zeros. And then slash 25 is 255.255.255.128, because it's 25 bits of ones. So the same as the slash 24, the same first 3 bytes are exactly the same, because that's 24 bits of ones followed by 1 more bit of ones and 7 zeros, because 32 minus 25, 7 zeros at the end of the subnet mask. So it's 255, 255, 255.128. And remember back to the numbers that we just saw, slash 23. Slash 23 is one fewer than slash 24. So it's 23 bits of ones. Subtract 1, it is 255.255.254.0. Again, we'll talk about some shortcuts in another video about how to remember these things and how to figure them out and how to figure out network addresses and all that stuff. This is just starting to get those concepts introduced. So hopefully that started to make some sense. Even if only a little bit, you'll get more familiar, and really the only way to remember this stuff is to do it and practice writing these numbers out and practice figuring it out. And remember that there's nothing magical about it. It's all just 32 bits. And these slash 24s are referring to how many bits are ones, and the subnet mask is just referring to where in the 32 bits represents the split from one side to the other, but it's all just ones and zeros. So if you see those things in action, you might see an IP address represented like this. You might see an IP address with IP address 192.168.5.0, subnet mask 255.255.255.0, or you might see that CIDR slash notation, just 192.168.5.0 slash 24, indicating that this is the subnet mask. There are 2 different ways to just represent the same thing, and down here you see the same thing, slash 20, 255.255.240.0. Just 2 different ways to represent the same numbers, so that when you see those things, you're familiar and you're ready to think, oh yeah, this is about, the slash 24 is referring to the subnet mask. So before we wrap up, check yourself. Is 255.255.242 a valid subnet mask? You might need to go back and look at that table of what are those valid numbers to see in a subnet mask. The answer is no, it's not. I don't usually give the answers in the check yourself, but I think it's important here. So no, it is not. 240 is a valid number, 252 is a valid number, but 242 is not. And then finally, what is the most common way to see an IP address represented? You see them all over the place. What is the most common way? And I'll give you a hint, it's not as binary digits. And that is IPv4 addresses, at least the start.